Yeah, so I will close here further, right? Not a good, not a good number, this one, molecular weight and specific gravity. Okay, so let's consult the tab, the manual. Okay, this one. To ensure comparable results are achieved, please repeat the steps outlined using these new values, 230 and 0.85. Okay, as otherwise the results of all subsequent steps will be different from this guide. Okay, 230 and 0.85. Clear boiling points, calculate again, auto match, quick calculate, calculate. Now it becomes closer. Okay, the correct laboratory value is 661. This result is quite close. And the oil density, quite close. And this one is quite close to the real value, which is 814. Okay, so with these values, a reasonable agreement between measured and calculated liquid density and also the GOR can be achieved. However, the calculated saturation pressure is a bit lower than reported. Okay, so this is okay. Exit, phase envelope, calculate. All right, this one. This is the laboratory, and the calculation based on the new molecular weight and specific gravity is lower than the laboratory data. Okay, so quite unfortunate there, but yeah, this is not the end of the day. Exit. Okay, so from here, let's open again the manual. Okay. So that the future changes to the pseudo can be easily undone, save the properties in the original number store by clicking on store in the pseudo prop screen, selecting the use original pseudo props from store to this one. Ensure that when auto-matching the critical properties of the split pseudo, the same liquid density is achieved. Okay, so from here, we will click store. This option will destroy the existing pseudo archive data. View can be used to check archive contents. Do you wish to continue? No. Use original pseudo props from store. Okay. Okay, so let's be careful. Click yes. Okay. So we will this one use original pseudo props from store that ensure that when auto matching the critical properties of the split pseudo split pseudo, the same liquid density will be achieved. Okay, so go back here. So with this, we have now reached our next milestone as the EOS now reproduces the liquid density and the GOR. Although again, the saturation pressure is not very good. But anyway, as such, we would like to again retain the state of the EOS in case that we wish to revert changes made without having to start from scratch. As described before, this can be achieved via copy streams, facility, or by saving a separate copy of the file. Navigate to the main screen by press exit and save twice to create the save copies of the current stage. Okay, so we will copy and save, exit and save, exit and save. Okay, now we will Save again, right? This one, copy existing stream, and we will call it sudo props. Copy stream. Okay. All right. So this is the initial file. This is the current milestone. Now we will go back to the well stream. Okay. With the above in place, the EOS now reproduces the liquid density within about 0.2%. All right. The matching quality and the GOR within 0.9%. So this is sufficiently close to the remainder that can be achieved via the regression by adjusting, for example, the volume shift. Okay, I'm reading this message. So the saturation pressure, however, is only around 1980 compared to the real value, which is 2091 psia in the lab report and requires further tuning, of course. As such, the aim for the next step will be to expand the phase envelope. Okay, we will expand the phase envelope whilst maintaining the match on the liquid density and the GOR. Before introducing binary interaction coefficients, BIC, we will first attempt to expand the phase envelope and increase saturation pressure by splitting the pseudo into smaller constituent pseudo components. For this, we will first use correlations to estimate the composition profile and then lump these constituent pseudo components together into a number of pseudo components. All right, so this will be more challenging.